I see pictures of coastal inundation and flooding. What might happen in the next 100 years with the 200 million plus people who live in those low-lying coastal areas all across the globe. My name is Parag Vaze, and I do anything and everything that's needed to make Sentinel-6 project successful. Sentinel-6 is all about water. So this is a 1/3 scale model of the Sentinel-6 satellite. Sentinel-6 is a collaboration with NASA, NOAA, the European Space Agency, and also EUMETSAT in Europe to measure sea level. This sort of top half of the satellite houses the main instruments. The history behind this goes back 30 years. I've worked on Topex Poseidon, JSON-1, JSON-2, JSON-3, and now Sentinel-6. All of them are the same series of missions. It's a great feeling of satisfaction. I had aspirations right from childhood to somehow work in the space industry. I knew that I wanted to work in something that made a difference. This is the room where we developed, integrated, tested the Sentinel-6 instruments, and then right here is where we packed it up also before we shipped it to Germany. Seeing that come to fruition is a personal satisfaction and an emotional satisfaction. The importance of this project and where it touches is on all walks of life all across the world.
Welcome, everyone. I'm Marina Jurica with NASA's Jet Propulsion Laboratory in Southern California. You may know NASA best for exploring other planets, but we are also keeping a close eye on our own planet Earth. NASA is about to launch the US and European Sentinel-6 Michael Freilich satellite. This satellite aims to collect the most accurate data yet on sea level and how it changes over time. JPL manages the Sentinel-6 Michael Freilich mission for NASA. Program manager Parag Vaze is not only in charge of the Sentinel-6 satellite operations here at NASA JPL, he has spent his entire 30-year career studying the Earth's rising ocean and is excited for this satellite to continue that legacy. He joins us live today to answer some of your questions. If you have any questions you'd like to ask, you can leave them right here in the comments or post them to social media with the hashtag #SeeingTheSeas. Thanks so much for joining us today, Parag.
Thank you. I'm really happy to be here, and would love to talk with everybody and give some feedback on what it's been like to work on these missions, and especially looking forward to the launch of Sentinel-6.
We all are. Can't wait until November 10th. Now, Parag, I know you've been involved with the mission studying sea level for 30 years now. Why is it so important to have this consistent and continuous record of sea level changes?
Yeah, it's really, really important to know what's happening, all the time, because even though we know the oceans are changing, they're changing slowly, but they are changing and rising. But things are going up and down, and those ups and downs as it's rising is very, very important because it tells us what's also happening in other parts of the world, including what's happening across ice sheets or other terrestrial surfaces. So really understanding and monitoring closely that trend and continuously is very important.
And what's great is Sentinel-6 will be offering us another 10 years of observations. So that's incredible. Tell me a little bit about what you think the neatest thing about this spacecraft is.
Yeah, so I think first of all, it's sort of the genesis of the spacecraft itself. It's really the story behind the building of it, and building first that partnership with ESA and the European Space Agency, EUMETSAT, others to build this continuity mission is a challenge itself. But the engineering that's gone behind building this and really looking at what's happening to maintain these precise measurements and to do it better. On Sentinel-6, we want to continue it and do it better, get better resolution, better accuracies, and much more close observations of what's happening on the coast. So really understanding, what it takes to build such a system and really make it operational so that we can have data out there is extremely challenging and extremely exciting and fulfilling.
What has it meant for you personally to have been on this journey now for 30 years with this legacy of satellites, basically your entire career? Did you think this is where you would be?
Yeah, I did not think this is where I would be. I knew that I was excited to work at the original contractor, Fairchild Space, which built Topex Poseidon. But as I was working on it, I really didn't understand how this was going to make a difference. And as I continued working on it, and particularly as I came to JPL to support that, I think I got a much better picture of the whole picture and got to work with all of the people that it takes to make this whole measurement fulfilling, including the end users, scientists, and understanding that really made it a passion of mine to not only build these kinds of missions, but really be able to see them succeed and deliver and help what's going to be happening in understanding the future of our planet. So that really has been my passion in bringing these missions and continuing them for the future.
That's so wonderful, Parag. And I know when we've had our conversations before, you told me that there's this global community that uses the data from this satellite, and it impacts each and every one of us.
Yeah, we've been fortunate to be able to work, particularly as I've done for the last 20 to 30 years. That as I not only meet the scientists, I actually meet people who are using the data, or I meet people at different agencies who are using the data in ways that I never imagined. We always talk about sea level, but people come up to me as we're doing open houses or as we're talking to other agencies, and they say, "Hey, I'm using the data that you're supplying, and I'm using it, as I'm planning my fishing trips." Or companies tell us, they're using it to plan, how they're going to be managing their fisheries and other things. So it's amazing the kinds of applications and the applications throughout the world. I've seen every corner of the world, right from Australia, Vietnam, rich countries, poor countries, it doesn't matter. People are interested in using this data, especially since our goal is to make it free and accessible to everybody.
That's so amazing, and it's so impactful to each and every one of us. Well, let's get over to the social media questions now, Parag. Nerdless on Twitter asks, "It seems to me that the accuracy of a few centimeters that Sentinel-6 is capable of will not be able to detect millimeter changes over its 5-year mission?"
Yeah, so we're not taking one direct measurement. A lot of these measurements that we're doing are taken continuously, and scientists are really looking at averaging that data and looking at trends. So those sorts of trends with those sorts of algorithms and averaging and analysis, sometimes we even improve the algorithms that we are applying as we're learning the behavior of our instruments and measurements, and we come back and reprocess that data. So as we look at the data, not on a snapshot of what we took, but months, if sometimes even years of data, we are able to really look at millimeter types, trends, which is really what drives our ability to understand things like acceleration, not only how much it's grown, but how quickly it's growing, which can be in millimeter type scales.
And then letting us know how we need to react. Brandon on Twitter asks, "What will it be seeing when orbiting over land?"
Yeah, so we're running the instrument and the satellite all the time, including over land. But one of the things we have been improving over time, of course, we want to measure what's happening in our open oceans. But this same kind of technique also gives us data as we fly over other water bodies, particularly large rivers, lakes, reservoirs, And as time has gone on, our teams have put together algorithms to really be able to understand those returns and also be able to provide some measurements of what's happening over land as well.
And Bonita on Facebook asks, do you have certain expectations from ground research which you hope to be confirmed with data from the satellite?
Yeah, so I think, getting these kinds of measurements, somebody else was asking, how do we look at centimetric or even millimeter types of scales? And part of that, of course, is what we're doing on the ground on being able to calibrate and validate it. The data, there's a calibration function where we might have specific features or targets that we set up to be able to understand and calibrate exactly how good and correctly we're making these measurements. And then we have other campaigns where we're looking at validating that data using all kinds of ground-based or in-situ techniques, right from ships to underwater gliders to moorings to all sorts of measurements. And we're also taking measurements and looking at measurements from other satellites and combining all of these together. We have a large science team who really helps to look at all of this data, combine it, analyze it, and ultimately validate it, so that we're able to really rely and trust this this measurement and the products that we're putting out.
And I think it's really fascinating how the altimeter works. And Stella C., who's a fourth grader, hey Stella, wants to know on YouTube, how can you measure sea level from space?
Yeah, so Stella, it's really great to hear you ask that question, because it's a fairly simple technique in principle, because really what we're doing, just like if you had your cell phone or anything else that's really working wirelessly, we're transmitting basically a radio signal from space. And just like you might receive a signal back, again, on your radio and maybe now on the internet or other ways, we're really trying to measure once that signal bounces off a surface like the ocean, how long it takes to receive that. Now, you can do that very, very simply and get a crude measurement, but we are trying to do it very, very precisely. So we're trying to basically use that same technique and really analyze closely how that signal is being reflected, how long it takes, and what it looks like. And with that basic principle, we're able to make this measurement. And of course, we've improved that over time, not just in the last 30 years, but things have been developed even before that.
And going back to what you touched on just a little bit ago, Parag, when it comes to this global community that you'd like to offer this data up for, Peter on YouTube remarks, what are some of the future applications you hope for with this data?
Yeah, so let me, before I answer exactly that question, somebody asked me a while back, what was the most unique and unexpected application of this data. And a few years ago, I think everybody knows about the MH370 disappearance of the Malaysian Airlines jet. And I was amazed to see how much the Australian agencies, which we work with as one of our users, had used this data to really map out what's happening with the ocean and applying it to even that mystery. I hope one day they totally solve that mystery. But, there's applications. I was talking to another representative of an NGO who was telling me, hey, waterborne disease is a big thing that they're working on, and they love to help the world community on that, and understanding how water moves, how it changes. I never imagined that that's one of the things that could be helpful to that community to understand, for example, how waterborne disease spreads, changes over time. And maybe, again, it's something that could be used to improve even in those areas, which I never imagined.
Yes. Now, Shay on Facebook asks, could you talk a little bit about your pre-industry life? For example, how did you end up with such an exciting job?
Yeah. So I would say my personal experience is, the small events, make big changes. I did have a fascination with working in this area, but I didn't have a 20-year plan that I had planned right from university. But I knew people who worked in this industry, and particularly at that time, I was fascinated with satellite and satellite telecommunications. So I actually first started working very, very briefly in the satellite telecommunications industry, and learned a bit more about how things work. But then I was fortunate, maybe through a life circumstance, because actually our company was bought out and merged, and I was looking for better opportunities. And I was really lucky to be able to find one at Fairchild. But the second part is really, again, in having, let's say, the good fortune to be able to work with people who really mentored me and guided me along the way. So I think that effort and perseverance and persistence does pay off in one form or another.
And speaking of that guidance, Parag, you were friends with the late Dr. Michael Freilich, whom this satellite is named for. That was a really incredible day. Then we all found out that it was going to be named after him.
Yeah, it was definitely an incredible day, and one of the most deserving people that I would think for this honor. He was. I certainly worked with him over the course of many years. He has some history even at JPL, even before some of the altimetry projects. But Mike had he led by example. So I think my most memories in terms of getting personal advice was really by example and guidance as we went through working on these missions. Things don't always go smoothly, and things don't always go exactly to plan. He was always very systematic at looking at whatever our challenge might be, and being part of the team to help us solve it. And really, that was an inspiration, not only in terms of building and promoting these programs for the future, but really motivating the teams that are behind it by example. Mike was definitely a very great spirit in terms of conveying that.
Samiksha on Facebook asks, what are major observations that you would like to share when you started working on satellites then and now?
Yeah, I think the satellite industry and satellite technology existed, of course, 30 years back, so that wasn't very new. But some of the technology definitely is things that have changed well over time. I think when I started working on TOPEX, one of the things I worked on was the actual flight software on the TOPEX satellite. And we did that all in the lowest form of computer programming that one could think of probably at that time, in assembly language, literally zeros and ones almost. So that was a very unique, but a very much unstructured way of doing things, where we basically engineered things, found the right solution, but didn't necessarily have let's say tried and true processes. Now, as time has gone on, the tools, technology has grown, but also the processes have grown, and the processes being more standardized, even with our international partners, is something that really didn't exist, at least that I remember, but has really come a long way. So that's one of the things that actually enables us to work with industrial partners, but also international partners, because we apply a lot of standards that we've all learned.
And Parag, this is the first NASA European Space Agency Earth mission that's joint. Am I correct?
Yeah, of course, NASA's been working with the European Space Agency in many, many years, but this is the first in Earth science, and in particular as part of their Copernicus program, which is a significant Earth observation program. It has been a tremendous collaboration, I have to say, right from all levels, whether it's the agency management, but really at the project team and also with their industrial partner, which is Airbus. We've really committed ourselves at the beginning of the project to work very, very closely in a transparent, collaborative manner. And I there's numerous instances as we've gone through the last few years where we've had challenges on one side or the other, and people have really stepped up as true partners to help us solve that problem and do it in a good way and keep us on track, which has been part of our objective, but also our success to date.
And speaking of success, we have a lot of questions coming in about basically how the satellite works. Six Silver Stones on Twitter asks, which orbit is this satellite going into?
Yeah, so it's going into an orbit that's 1,336 kilometers high, and it's an orbit that's also inclined, at 66 degrees. So it's a particular orbit that was chosen in the days of Topex Poseidon to have to be able to cover the Earth and in these tracks within 10 days. But also to be able to use these measurements and correct for other features like tides and so forth. When I described how we literally take the sea surface height measurement, that's true, but there's a lot of factors that really affect the quality of that measurement and accuracy. And things like tides, for example, are one of the factors which can be corrected in this particular orbit. So this orbit was chosen very specifically for this particular type of measurement. And then as a continuity, we've kept that exact same orbit, for all of the series of missions that we've been doing.
And Miriark on YouTube asks, what's the kind of scale of the data you look at before processing?
Yeah, I mean, if the scale means something like what sort of volumes of data that we're looking at, but the data that we're first measuring is literally what we call level 0 data. It's literally the raw data as the instruments are putting out, and the first challenge is collecting all of that data and transmitting it to the ground. So over the course of a day of an orbit, we're trying to downlink as much data as we can. Somewhere close to where we're trying to downlink several hundred megabits per second, which on your computer on Google might not sound a lot if you know some of the specifications, but doing it from space and doing it in a timely manner, in a robust manner, where we also don't lose that data in the transmission, is quite a challenge. And on Sentinel-6, because we've enhanced some of this capability, that data rate has grown significantly, more than doubled or tripled what we've had in the past missions. But our technologies have also improved so that we can process that data and also produce the products and transfer them, really within 3 hours.
That's really exciting. What a great turnaround. Stygian on YouTube asks, will Sentinel-6 be able to measure underneath sea ice?
Yeah, so this is not something Sentinel-6 can do in terms of being able to measure underneath sea ice. But, the study of sea ice is being conducted by a lot of scientists, and they are all using measurements, including they will be using measurements from Sentinel-6 to really understand what's happening at the very top layers of the sea ice, but also what's happening at the edges of a lot of these sea ice, because there's a lot of ocean interaction with the sea ice, and our data will definitely be used to help understand what that interaction is. Some of that, is being looked at in terms of even in terms of how glaciers are moving, how they're changing, and sometimes how they're diminishing. So all of this data is very important and is being utilized and is being planned to be utilized even further for even study of sea ice, glaciers, et cetera.
Navid on YouTube asks, can we measure rivers using Sentinel-6?
Yeah, so I was mentioning earlier, this is one of the things that's not part of our normal mission objective. We're really focusing on the oceans and so forth. But we are taking data over surface waters, rivers being one of them. Now, our satellite and the instruments aren't tuned to measure, every water body that's there. So we are able to take measurements on rivers, particularly if they're very large rivers, and be able to use those. And those measurements are being taken and being used. There will be future technologies. One of the projects I'm also excited about is called SWOT in the future, which will really look at much more precise measurements, particularly on surface waters. But this data from Sentinel-6 will be a very big pathfinder towards being able to fully exploit that data in the future.
Now, 2020 has given a lot of us many curveballs. Russ on Facebook asks, what is the biggest surprise 2020 has given your team?
Right. Well, I think it's the biggest surprise the world has experienced, of course, with the pandemic. And, it was also another spirit of cooperation when that happened, because I think the first reaction from our partners and our project team wasn't, how do we throw up our hands and give up? It was actually exactly the opposite. Is yes, we want to be safe. We want to keep everybody safe. But are there ways that we can work together to continue our progress? So I think I remember about March 22nd, I remember it very well in terms of the exact date. We worked very closely with our partners to figure out ways. And I have to say, in the past, when under normal circumstances, when I might talk to a person, whether it's because of IT issues, challenges, the answer would be no. And now the answer, pretty much from everybody is, how can I help? And that was really the spirit that helped us continue. It did take effort, sacrifice, long hours, things that had to be done maybe more slowly. But really the objective was always, how can we help to keep things moving forward, which was amazing, because this was really another demonstration of our partnership spirit.
And especially since you had so many different time zones to work throughout. So you guys did an amazing job. Now, Gerard on YouTube asks, how many total years of data do you have? And Parag, maybe you can also go into the future now that there are 2 satellites that Sentinel is a part of.
Right. So, I mean, of course, the data record as it stands today, started back with Topex Poseidon. And as we've been saying, we've got almost 30 years of data. Our plan for Sentinel-6 is to have 2 satellites built, one launched now, and then the other put in storage and launched 5 years from now. So the primary mission life of each of these satellites is at least 5.5 years, although I think every single one of our satellites that we built, thankfully, has really lasted longer. But the primary plan is basically to operate and get at least 11 years of total mission life and continuity out of it. We're expecting that Sentinel-6 Mike Freilich is going to not only last the 5.5 years, but actually go beyond that. We're expecting probably for another 2-year extension as a goal for each of these. So in all total, if we're somewhat have done a great job on the engineering side and somewhat lucky. We're really expecting things to go out maybe up to 15 years, but that doesn't mean that we want to rely on that and that only, because we really like to have this overlap between an existing satellite and a new satellite. So part of that, anywhere between 11 and 15 years is making sure that we are have a good overlap, and that we can ensure continuity of how precise and accurate the measurement is.
Yes, as we've said over and over, a continuity, consistency, that's what makes it move forward when it comes to understanding sea level rise. We've got a great question from Reese on Facebook. Hi, Parag. Reese from Orbital here. Will there be coincident science between Sentinel-6 and OCO2?
I think I don't know the exact answer to that, so I'll be direct. But what I do know is, and what we are trying to do across all of these systems is, we're of course trying to gather data about continuity of the oceans and sea surface height. But really, what I've seen as a change, not a change, but a growing emphasis, particularly in the last 5 to 10 years, with our scientists and scientific community, is really the combination of measurements from various platforms, not just satellites like OCO2. But the answer is that people ultimately, sort of the holy grail thereafter, is really trying to understand how the Earth works, and that means it's the atmosphere, it's the ocean, and understanding that connection and relation is something I definitely know will be utilized by the science community. By the way, nice to hear from somebody at Orbital, which was an organization I worked with as part of Topex Poseidon. So nice to hear from you.
And our last question is from Barbara on Facebook. She wants to know, will this data be shared with Zooniverse to give citizen scientists the opportunity to help with the data?
Yeah, so I'm not very familiar with that particular outlet, but what I would say is that our objective is to make this data fully and freely available. So we're really trying to not only promote and advertise where this data is available, but also that this data can be downloaded, hosted in many different areas and platforms by many different organizations. So, if we are not making that connection, please reach out to us, because we're very excited to make a connection with anybody and everybody and facilitate that in any way possible.
Well, thank you so much for all of you folks who reached out on social media and joined us today. And thank you so much for joining us, Parag.
You're welcome. It was a pleasure. It was really great to talk about this project, and look forward to the launch.
We are all looking forward to the launch. The Sentinel-6 Michael Freilich satellite is a true international collaboration, as you heard Parag mention. It is being jointly developed by the European Space Agency, NASA, the European Organization for the Exploration of Meteorological Satellites, and the National Oceanic and Atmospheric Administration, with funding support from the European Commission and technical support from the French Space Agency, CNES. The Sentinel-6 Michael Freilich satellite is scheduled to launch on November 10th. For the latest on the mission, follow at NASA Earth on Twitter, Facebook, and Instagram. You can watch all of the Behind the Spacecraft video profiles on the NASA 360 YouTube channel. We will be doing Q&As with Sentinel-6 Michael Freilich satellite team members on Wednesday afternoons for the next couple of weeks. So please follow and subscribe for notifications. At NASA Earth Science, your home is our mission. Thank you for watching.